with grooves for better gripping. Then they add a protective black coating. A worker inserts a tension bar into a quick release lever. The lever allows the rider to detach the wheel from the suspension fork. He presses a fastener into the lever to secure it to the bar. He lubricates the tension bar with grease. Then he inserts the bar into the wheel axle, joining it to the lever. A steel pin holds them together. An employee places the inner fork upside down in a hydraulic press. He inserts the steering tube in the center hole and activates the press.
Watch how things been manufactured.
Then he lubricates one of the tubular legs and the upper part of an air spring. He pushes the part through the bottom of the leg. It slides to the top where he installs an adjustment knob.
Let me get something now. Okay.
He inserts the lower part of the air spring into the leg. The air spring allows the suspension to move up and down. He snaps a collar on the end to lock the air spring in place. The damper is next. It's a piston and oil compression mechanism that absorbs energy. He pushes it into the second leg of the fork. He screws a threaded collar and valve into the top of the damper leg. He adjusts the damper's position. He adds oil to the damper using a fill sleeve to prevent spills. He pushes a rod through the damper to get rid of any air. Once the damper is full of oil and air-free, he installs the top cap and seals it with a gasket. He screws a base ring onto the gasket. Then he installs the compression knob we saw machined earlier. The knob allows the rider to adjust the compression of the oil. With the inner fork complete, they now move on to the outer fork. An employee inserts bushings in the tubular legs and activates a two-pronged press. The press pushes bushings securely into the cavities. He secures the inner fork in a jig upside down and slides the outer fork onto
No more
it.
iPad. From now on, we have a TV.
He lubricates the spaces between the inner and outer
I'm going to
forks.
teach you how to create manufacturing.
After bolting the suspension forks together, he increases the air pressure in the spring.
To think
And
how they
caps the air fill
manufacture
valve.
things. I need you to listen.
Now for testing.
They are creating the suspensions
A motor
of
moves the
the
fork up and down,
bikes.
simulating a bumpy ride.
Forget about this. The next one you're gonna
A
watch.
computer
okay?
monitors the suspension
But
fork's
look-
performance.
Hear to what they are saying.
After passing the test, a worker applies brand decals to the fork. Finally, he slides
No,
the
I
axle
don't need
into the
you to
lower
remember.
part
I
of
need
the
you
fork
to
and
watch.
secures it.
We're gonna catch you. And then
This
You're
mountain
gonna
bike
think
suspension fork is
of a
complete.
product that you can manufacture yourself and make millions
Now,
of dollars.
the technician
from.
fits it to the front of a bike. He attaches the handlebar to the steering tube with a nut and a long screw. Next, he attaches the wheel to the fork with the axle.
That's what I need you to do.
It takes just 2 hours to make a mountain bike suspension fork,
2 hours.
but they're strong enough to last through many more hours on long, bumpy mountain trails.
Guess how much they're gonna pay that? They're gonna sell it to manufacturers by 110. See, $1,000.
What do you mean?
Humans have been performing surgery for over 7,000 years, but the use of surgical sutures is fairly recent. Ancient Greek surgeons were thought to be the first. They used
Great.
gut strings to mend the wounds of gladiators over 2,000
Look.
years ago.
This is good.
Today's medical sutures come in different forms, such as synthetic
Medical
monofilament
sutures.
threads,
Learn how to
natural
manufacture.
collagen fibers,
I don't know.
or braided synthetic threads. A technician sets a tension meter to check the quality of the raw materials. The machine applies tension on the knot to measure the force needed to break it. A worker tests the material's absorption process in a heated bath. This simulates the temperature and moisture of the human body. A technician enters the product's medical specifications and prints out a batch of labels. Then, a supervisor selects needles and places them on a table. He retrieves spools of thread from a refrigerated room. To preserve the thread, it's been stored in sealed containers. The supervisor gathers all the materials and brings them to the material preparation department. The supplies are passed through an airlock to maintain the department's positive pressure environment. On the other side, a technician opens the airtight foil and removes the thread spool. She threads the spool in a custom-made winding and cutting machine. The technician sets the mechanical thread counter back to 0 and starts the winder. It can wind threads that are up to 100 inches. The counter tracks the number of windings as the machine unspools the thread. The machine stops automatically once the winding is complete. The technician applies medical-grade glue to stiffen the ends of the braided threads before cutting them. She places a guide to hold the threads in place while she cuts them along the glue line. Sutures use needles of various shapes and sizes, the smallest ones being 10 millimeters in length. On the main production floor, dozens of workers attach needles to the threads. They make sure the attachment meets the suture's requirements. The operator inserts the glue-hardened end of the thread into the back of the needle and crimps it tight with a mechanical swaging machine. Then she hooks the needle into a pull tester to check the strength of each attachment. Finally, workers wind the assembled sutures into folded holding cards, tucking the needles in for protection. A worker inserts the holding card in a labeled foil pouch. Then he slips it in a second package made of medical paper and polypropylene film, and feeds it into a continuous rotary sealer. The sealed packages drop into a production holding basket.
Wow. I'm gonna do
The
that.
finished product is sent for terminal sterilizing. A worker places the basket into an ethylene oxide or EO gas sterilization bag. She attaches a biological indicator vial and a control strap on a sterilization control card and puts the card inside the bag. She adds an EO gas delayed release canister in the bag and places the sealed bag into the sterilizer. Sutures can be used for a variety of procedures, but each product has a very precise application.